Hey everybody, welcome to today's Getting Started with Kubernetes and Rancher online training. I'm not sure, it looks like we just have a couple people on the line right now. I have a pretty cozy class today, but really excited you are all here. We have about 90 minutes scheduled with each other. We have a lot of demo to go through, so I'm going to try to get through some housekeeping items first so that we can get on to the heart of our material quite quickly. And while people are joining the line, I want you all to know that this session is being recorded. So if you do need to drop off for whatever reason, don't worry, you'll be able to revisit the demo and the concepts and everything later on. We will email you the slides and the recording after the training. So as a way of introduction, actually, let me just go over a couple of our objectives and goals today. So, we really want to give you a solid technical introduction to Kubernetes. Using Rancher, we'll go over Kubernetes concepts, workloads, components, architecture, and we will show you how to get a lot of great things done using Rancher. We do have slides to help educate and explain these ideas and these tools. But we try to be very hands-on, so we have a lot of demo to go through. We can use that to answer questions. So we try to be as responsive as possible to what you all want to learn. So please ask your questions. There's a questions tab where you can let us know what you want to know more about. If for whatever reason you want it to be private, just let us know. Otherwise, we will answer it aloud for the benefit of everyone, so it can be a teaching point. And we do our absolute best to not leave before every question is answered. So if you do have one, please ask it early and often. There also is a survey at the very end. So if you're able to stay for just a couple minutes after the training and fill that out, it really helps us get better at teaching, get better at delivering the information that you all want to know about, and come up with new topics and new classes to get every learning wish fulfilled, so to speak. So as a way of introduction, my name is Matthew Scheer, Marketing Manager here at Rancher, Community Advocate. Please reach out to me if you are looking for a resource or have a question. I'm happy to help, kind of be a point of contact for you. And our presenter on the line is engineer Adrian Goins. Adrian, are you there?
No, I'm not here. Hey, everybody.
All right. Okay, cool. Well, I'm glad whoever you are, you're here. Adrian will be doing the presenting in just a moment. A couple other housekeeping items before we get going, and I want to point out the Pound Rancher training hashtag there. You can use that on our Slack channel to get connected on Slack for these trainings. Where we post files and let you know about upcoming training sessions. So I'll talk more about Slack in a moment. But before we get started, we hope that you come to this training with some basic container or Docker concepts under your belt. If you don't, that's totally okay. We try to make this super accessible. And like we said, we're happy to answer your questions. We also do have a lot of great container and beginner level material on rancher.com. So if you go to our blog or you just click the search button in the top right or go to the resources tab, you'll be able to find a lot of tutorials and concept articles to get you going. And if you want to have your own instance of Rancher going while Adrian goes through his demo, then just go to rancher.com, click the deploy button, and you can get up and running with Rancher in just a couple minutes. Rancher is totally free. It is open source. You can download it and use it to your heart's delight. And we have a really thriving community around Rancher and our other products and projects and Kubernetes. So if you go to slack.rancher.io, join our Slack channel. There's thousands of members and hundreds of people asking and answering questions every day there, and lots of different channels on specific topics. We also have a forum, so forums.rancher.com, totally free to join as well. We make product announcements there, and you can find in-depth conversation going on there as well. So with all of that out of the way, I'm going to pass this presentation over to you, Adrian. Make you the presenter. Here we go. Okay, you should have control, and I see your screen. You're good to go.
Fantastic. Hey everybody, my name is Adrian Goins. I am super stoked to be here today because this is actually probably my favorite thing to do during the week. It's the one time of the week that I really get to interface with the community and talk to you guys about something that I love very much, which is Kubernetes. So every week, I rearrange my slide deck to try and give you the most effective presentation that I can. And every week I totally screw it up because there's so much stuff here that it's hard to pick and choose. We just don't have enough time to go through everything. So I will try my best today to keep things under the time limit. But like Matthew said, how many people do we have here? Oh my God, it's such a cozy class. There's something wrong with the website, and we discovered this morning that the registration page is somehow not present. So those of you who found it have like super ninja skills, and we're even more excited that you're here because there's probably 40 other people that wish they could be here and aren't. Anyway, I'll do my best to keep it under time. If you have questions, ask, and we'll do a couple of question and answer sessions, one at the end of the Kubernetes section, and then one towards the end of the webinar itself. So I'll just dive in. This slide is boring, but it's important. Kubernetes is a framework, and as a framework, it's not going to tell you how to do things. It's super flexible and it's super powerful, but it expects you to decide how best to leverage that power and flexibility to make it do whatever it needs to do for your specific use case. In order to maintain that power and flexibility, it also stops at a certain point and says, this is all I'm going to do. Beyond that, you can plug tools into it to do other things. So anybody who deploys a Kubernetes cluster immediately encounters what we call day two operations. Day two operations is basically, now you have a Kubernetes cluster, good for you, what are you gonna do with it? There's a bunch of other stuff that you have to do to really make it enterprise worthy and ready for use. This slide lists a few of the questions that you might have. So for example, consistent deployment, access control, plugging it into a backend identity provider, cluster partitioning for single cluster multi-tenancy, high availability, security policies, monitoring, metrics, and a whole host of other things are questions that you're going to have to answer. Rancher wants to help you answer those questions. We've learned over the course of doing a billion of these trainings that most of the people who come here are interested in Kubernetes and may not have even encountered Rancher yet. So Rancher takes Kubernetes and basically treats it as a commodity. So at the bottom tier here, we've got infrastructure. We already know that's a commodity. Bare metal, cloud provider, who cares? Infrastructure is infrastructure. Above that, you've got all of these options for Kubernetes. You can get it from a hosted provider. You can get it from yourself. You can use our Kubernetes engine. It doesn't matter. Kubernetes itself is a commodity. It's like electricity. I kind of don't really care where my electricity comes from. All I care about is that when I flip the switch, my lights come on. And I actually live in the Central Valley of Chile, and I have a really terrible electricity provider. So it's really important for me that when I flip the switch, the lights come on. Above that, Rancher provides, let's see, how can I best say this? So Rancher can deploy Kubernetes for you. It can deploy it into anything, basically anywhere, hosted, cloud, compute instances, bare metal, vSphere, it doesn't matter. Rancher can deploy it. And then on top of it, Rancher begins to provide value in a number of different ways. One, it can plug into a backend identity provider. So now you have the ability to deploy security policies uniformly across all of your clusters from a single place. That's an example of something that Kubernetes doesn't do very well. And if you were to do it with Kubernetes, it would take you a long time and be prone to lots of error. Rancher identifies all of the places in Kubernetes where things take longer than they should, are harder than they should, just really want to make you claw your eyes out. And we give you the tools to do all of those things quickly and effectively, getting you to the place where you can actually use your cluster. And that's what I'm going to show you how to do today. We used to start with the Kubernetes stuff, and then we would go to the Rancher stuff. And then invariably, we'd never even get to the Rancher stuff because I talk too much about the Kubernetes stuff for all the aforementioned reasons. So I've switched that around, and we are actually going to do a Rancher installation and then we're going to do a Kubernetes cluster installation, and then we're going to use that cluster from the command line, and then we're going to go back and we're going to do the same stuff through the UI. So where's my browser? Rancher has fantastic documentation. This is just go to rancher.com/docs or docs.rancher.com, or go to the website and find wherever we have the docs page. There it is up there. And everything you need to know about installation and use of Rancher is here for you. There are two ways that you can do a Rancher installation. One is just for playing around. We call it the sandbox, and that's a standalone Docker container. That's how we're going to do it today. That's not for production. That's for playing around. At this particular point in time, there is no way to go from a standalone Docker container to a high availability Rancher installation. So if you're going to play with this, cool, but if you think you might use it, I recommend that you go with the HA install. Now there's the way that the HA installation works is it'll walk you through an installation of Kubernetes using Rancher Kubernetes engine, and then it'll walk you through how to install Rancher with Helm, and it's a little complicated, which is why we don't do it in this class. But later towards the this is where I screw things up because I change things around. Later on, I'll point you at my YouTube channel where I have a bunch of videos on doing all sorts of things with Rancher, including how to do what we call a single node high availability installation. What this allows you to do is if you don't want to dedicate 3 nodes for Kubernetes to Rancher at this point in your journey, you can still stand up a single node Kubernetes cluster and install Rancher into it. And later, if you say, you know what, this is awesome and I want to keep using it, you just add 2 more nodes to it and it's fully highly available. So again, that's more complicated than what we can show today. So for today, we're just going to do the single node installation. Ta-da! I'm not going to read you this. I'm just going to show you how it's done. The Rancher server is a Docker container. Whether it's installed directly or whether it's installed into a Kubernetes cluster, it's just a container image. The current stable version is actually 2.2.6, but like I told you, I live in Chile. It takes a while to download things. I already have a copy of 2.2.4, so that's what we're going to work with today. I'll explain this in a second, so don't be alarmed. Boom. Docker run, put it in daemon mode, restart unless stopped, pass through port 80 and 443. And then I like to attach a directory from the host into the Rancher container for persistent storage. This makes it really easy to do backups, and I talk about that in my videos as well. And then we're going to run the version 2.2.4 image. Blah. Yeah, it's going to go off and do a bunch of stuff. Now, Rancher is super cool because you see it's creating all these CRDs. Rancher actually runs inside of Kubernetes. It's not a separate thing. If you deploy this into a 3-node RKE cluster, then it's part of Kubernetes, which makes it possible for Rancher to interface directly with the Kubernetes resources, the API, all of the Kubernetes stuff. It's part of the soul of Kubernetes. Come on. There we go. By default, it comes up with self-signed certificates. You can use certificates from Let's Encrypt, or you can use your own self-signed, or you can bring your own certs. But for the sake of the demo, we're just going to use the self-signed certs. It asks you to set a password, which apparently I didn't type correctly. There we go. And then it asks you about this server URL. This is important. This needs to be reachable from the clusters that Rancher is going to manage. So if you're running a Rancher server in your office, you try to launch clusters out of AWS, whatever you put here, the AWS cluster needs to be able to reach. Theoretically, it's possible to change it. In the video that I'll be releasing on Tuesday, I'll show you just how kind of not true that is. It's tricky. So just get it right the first time because it'll save you pain and suffering. This is the main view. I'll come back and talk about these global options in a sec. First, we're just going to add cluster. You see here that we can actually provision a cluster out in any hosted Kubernetes provider. We can stand up infrastructure on cloud providers, and there's way more that we support besides just these 4 here. I just only have a few of them enabled. Rancher is unique in that it can import existing clusters. So if you have a Kubernetes cluster already out there in the wild and you want Rancher to manage it, you just tell us here that you want to import it, give it a name, we'll give you a kubectl apply command, you run that on your cluster, it installs the agent, connects it back to the Rancher server, and suddenly Rancher can manage it. It's pretty dope. For anything that's not one of those previous options, there's the custom option. Installing Kubernetes normally, it's not very much fun. Rancher's distribution of Kubernetes is 100% upstream Kubernetes, but it's packaged in Docker containers. This makes it very easy to do upgrades and rollbacks, and means that you can install Kubernetes on any host that only has a supported version of Docker. If you're doing stock Kubernetes installation, you actually need to have a bunch of prerequisites on the host before you can even get to standing up a cluster. With Rancher's Kubernetes, RKE, you can literally go from nothing to deploying workloads in less than 10 minutes. There are a bunch of options here. If we're in a cloud provider, we would specify that, but we're not. So we're just going to click over here, say that we want our single node that we're going to deploy now to have all 3 Kubernetes roles, and it gives us a Docker run command. Take that Docker run command and come over here to this host, make sure not running anything, and we will just run that. And if we come back over here, you see that 1 new node has registered, and now Rancher's in the process of installing RKE onto that node. Like I said, it'll take a few minutes, so we'll let it do its thing, and while it's doing that, I'll walk you through these global options. When I did the installation, I said that there are other things that we support that aren't listed there. Here, for example, you have other hosted Kubernetes provider drivers, and we also had node drivers. You can add additional node drivers, or you can add additional cluster drivers for any other thing, and basically they're API information, or in the case of node drivers, Docker machine information that tells Rancher how to talk to whatever it is. Or you can just take something that's here, like OpenStack or Rackspace, and you can just activate it, and you can start using it. The package manager for Kubernetes is called Helm. If you guys use Linux, you're familiar with, depending on what you use, something like Yum or apt or Yast or dpackage or whatever. Those are package managers for Linux. Well, for Kubernetes, it's called Helm. What that allows is, instead of me writing up a big long how-to document of what to install and how to wire it together, if I have an application that I run in Kubernetes and I want you to be able to run it, I can create what's called a Helm chart. I can give you that Helm chart, and you just type Helm install whatever the chart name is, and optionally set some flags for it, and then you will get the same application that I myself am running. Rancher ships with a curated list of charts, which I'll show you when we get to the cluster side in a second. You can also activate the stable Helm repo or the incubator Helm repo and get access to hundreds of Helm charts that you can then run, well, that you can install to your cluster from inside of Rancher. If there is any external third-party Helm catalog, like from Elasticsearch or OpenFast or anybody else, you can just put the URL here, it will show up down here, and those charts will be available for installation as well. Rancher talks to a whole host of identity providers. You just tell us how to talk to it, and immediately you can start pulling in users and groups from Active Directory or whatever you've chosen, and then use those with role-based access control configured at the global level and then applied to the individual clusters to control cluster access. You can get super granular with this. The reason this is at the global level, and the reason this is so awesome, is that a single Rancher server can manage hundreds of Kubernetes clusters. And if you have to add and remove access from clusters all over the place directly in the provider's infrastructure, well, that's not very much fun. And even if you have to do it through Rancher on every single cluster, well, that's not very much fun. So Rancher does it at the global level. And now if somebody joins the organization, leaves the organization, whatever, you just enable or disable their account either here, or if you're disabling because somebody left, in the backend identity provider, and they immediately gain or lose access to all of the clusters that you have under Rancher's control. Super simple, super fast, really hard to break it. Same thing applies for pod security policies, which are an advanced Kubernetes concept that controls what types of things you're allowed to run inside the cluster. And then we get into some other stuff here. But our cluster, our single node cluster, is up and running. Now, if we had more than one cluster, they would all show up here. In this case, we only have one. And here it is. You get some basic information about it. If you have enough horsepower, which in the case of my little tiny one node here, I do not, you can activate advanced monitoring. Advanced monitoring will enable Prometheus and install a bunch of Grafana dashboards. You can use that to get super detailed information about what's going on in your cluster. It's great for figuring out who's hogging all the resources, for doing capacity planning, and just for understanding and getting alerts on stuff. It's always better to get alerts when things are starting to go bad than to get alerts when they've already died. At this top level, we have the CoopCTL dashboard, which I know is really tiny font. I apologize for that. This allows you to do one-off kube control commands, or you can grab the actual kubeconfig file for this particular cluster, and you can take that paste it locally, set my kubeconfig variable there so that I'm talking to the right cluster. And let's just take a look at that really quick. So this has all of the certificates and everything that you need to talk to your cluster. So if we set that, I can run kubecontrol get nodes, and there you see training A ready, and we're ready to go. I'm going to start doing stuff on the command line. And you've already seen that I typed some cool little shortcut commands. If you're going to spend any time with Kubernetes, you're going to have to love kubecontrol, and you're going to realize that you start typing the same stuff over and over and over again. So I'm going to introduce you to two things that are going to save your life. First one, CoopCTX. This is from Ahmet. CoopCTX and kubeNS allow you to quickly switch between contexts. So imagine you're managing multiple clusters. You need to switch from your home cluster to your DigitalOcean cluster to your production cluster. Rather than typing kubectl, that's a big long command, it sucks. You just type kubectx and then whatever your cluster is. Similarly, once you're in a particular cluster, there are multiple namespaces that you might want to work with. A namespace is a logical separation of basically names of things in Kubernetes. So you might have a dev namespace, a staging namespace, and a production namespace, each of which might have a deployment called website. In a single namespace, you can't have two things with the same name, so namespaces do segmentation of that. The kubeNS command works with a really cool thing called fuzzy finder or fast fuzzy finder, FZF, and it shows you all the namespaces that are on there, allowing you to select the namespace that you want. Otherwise, there are aliases. So you see I type KGPO, whoops, KGPO, and I have something else that expands that into the full thing so that you can see it. And I have somebody blowing up my Slack that I gotta, okay, fine, he's just gonna blow it up. Anyway, the next thing are aliases. Now, the same dude has lots of, hey, Matthew, are you there?
Yeah, I'm here.
Yeah, can you tell Jared that I'm busy? Because I actually closed Slack. I'd have to go open it on my phone to get him to leave me alone.
Will do.
Thank you.
No worries.
Thanks. Sorry about that. This guy's like, it's hitting my watch and it's like blowing up. Anyway, aliases. This dude, I don't know where he works, but he created all these crazy aliases for shortcuts. Now, I don't expect you to use these. I don't even know how he remembers some of them. But as you start doing more stuff with Kubernetes, and there are things that you're starting to do, like aliasing K as kubecontrol, just search in here and find the ones that you like, put them in your shell, and again, it'll make your life easy. All right. Let's start going through Kubernetes. Kubernetes is simpler than you think it is. It's just got a funny name and it uses funny words, but ultimately it's about really small objects that do specific things, and then you assemble those into an application. I'm going to go through a bunch of those today, and by the end of this class, you will be comfortable building and interacting with simple applications. A pod is the smallest unit of thing that you can deploy inside of Kubernetes. if you've done anything with containers, you know that like you can link containers together, but you start doing things like cross-host networking or like getting your Apache container to talk to your PHP container. Again, not very much fun. What a pod does is it collects multiple containers into a shared network space, meaning they can talk to each other on localhost, using shared storage so they can work with the same backend volumes, and then using a couple other shared things that aren't important for this class. Most of the time, you're just gonna have a pod that has one container in it, and that's fine. I don't like this slide. I don't actually think that pods are confusing. You already know what a pod is. If you've ever seen a seed pod or like one of those wasabi or whatever, the pea things that you get from the sushi restaurant that are coming in the little steam bowl, like it's the same thing. It's like you got an outer shell, it's got some things inside of it. You know what a pod is. Here's an example that I ripped out of the Kubernetes IO website that is a great example. You've got a file puller that pulls content from some external CMS system that people update. It writes that out to storage, and then a web server is responsible for retrieving that content when people ask for it and delivering it to them. This is a beautiful example of two containers that each do one thing, but together they provide greater functionality. And when you think about pods in terms of your application, you think when your application needs more horsepower, a pod is what you're going to scale. It's what you're going to clone. So you don't want like a web server and a database server, because if you need 10 more web servers, you don't also need 10 more database servers. So a pod should be a collection of containers that work together to provide a very specific function. Again, if you've done work directly with containers, you've encountered things like trying to run Apache and PHP in the same container, or trying to run multiple things where you actually need to install something like supervise so that you can start and stop services and daemon control and stuff. Kubernetes fixes all of that by simply giving you pods. Everything that you do in Kubernetes uses what's called a manifest. Manifest is written in YAML. Nobody on the planet likes to write YAML, but you need to understand how it works. And then throughout the course of this class, I'll show you several different ways to do the same things. Many of those don't involve writing any YAML at all. At the top level, you've got 4 keys: API version, kind, metadata, and spec. All your manifests are going to have this. For a pod spec, you've got kind is pod. Sweet. Metadata, we'll talk about that later. Spec, pod can have multiple containers. In this case, it has one. Its name is myapp-container. The image that it's going to run is busybox, and we're going to override the command by having it do this other thing. What that actually looks like is that. And you see that I shortened it. Now we're going to run this, and when we do, it's going to do what it says it's going to do, and then it's going to exit. What do you think Kubernetes is going to do with it after that? The way that you get stuff into Kubernetes is, well, one of the ways that you do it is you can take an existing manifest that you have here and you can apply it. Now, usually you do kubectl create, but Kubernetes is smart enough to recognize that if you apply something that doesn't exist, it will create it for you. That's just one less thing you have to remember to type. Okay, so we created it, it completed it. Okay, it's running, it completed, it gave us a new message. Crash loop back off. When you run something in Kubernetes, usually it's something that's going to stay running. So when it exits, Kubernetes doesn't know why it exited. It doesn't know that we told it to exit. All it knows is that it exited. So it restarts it, and then it exited, and then it restarts it. And after a couple times of doing this, Kubernetes is like, well, obviously there's something wrong. So I'm going to wait a little bit longer before starting it again. This crash loop back off is a timer that Kubernetes will increment from 5 seconds to 10 seconds to 30 seconds, and it will continue all the way up to 10 minutes. So that Kubernetes isn't trying to crush your cluster, starting something that obviously isn't working. We are going to delete that by just saying kubectl delete pod myapp-pod. Gone. You are never going to create pods. The reason you're never going to create pods directly is because they don't really give you anything useful. Like, you can start a pod, you can poke at it, but there's none of the control around connecting stuff together. Instead, pods are managed by what are called replica sets. You're not going to create replica sets either, but you just have to understand what they are. A replica set manages a group of pods, and you tell the replica set how many of those pods you want. So a replica set makes sure that it has the correct number of pods and that the pods are in the correct state, which usually is running. Imagine that you have 3 nodes. You've got 12 replicas of your application, and it's spread across 3 nodes. If these were just pods and one of your nodes died, Kubernetes doesn't care. It doesn't know that one of these pods is any more important than any other. But with a replica set, you've told it that you want 12 replicas. It sees that there's only 8 of them, and it launches 4 more on the remaining nodes so that it returns to the desired state. State is an important concept in Kubernetes. There are 2 types of state. There is the desired state, and there is the actual state. Kubernetes is always working to make sure that the actual state matches the desired state. So the desired state is 12 replicas, the actual state is 8. It will do its best to go start 4 more of them. But you're never going to create replica sets either. Replica sets used to be created by a thing called a replication controller, and it didn't do enough, so they created deployments instead. These are layers of abstraction. A deployment gives you a better set of tools for interacting with what it should do, and then it creates a replica set, and then the replica set creates the pods. Here's a deployment. The deployment has a name called Nginx, and it has a label of app is Nginx. Labels are important in Kubernetes. Labels are how Kubernetes finds things. So for example, if we jump all the way down here, you see that in our spec, it looks very similar to what we had before. We have one container with a name called Nginx, and we want it to run Nginx 1.14-alpine. And we're telling Kubernetes that it's listening on port 80. Up here, we say that we want 3 replicas, and the replica set should look for pods with a label of app is Nginx. In our pod template, you see that in addition to the container spec, we also say that all pods will have a label of app is Nginx. So that helps the replica set find it. Always label your stuff. If you don't, Kubernetes is going to give default labels anyway. Just become very comfortable with labels. They're arbitrary. They're just key equals value. You can have whatever ones you want. Role equals production, database equals whatever. It doesn't matter. So I could apply that, but instead, let's do it differently. Let's use kubectl create. We want to create a deployment called Nginx. We want it to run the Nginx 1.14 alpine image. You see that we now have an Nginx deployment. Which created a replica set, which created a pod. That was easy. If we delete this, we'll recreate it the other way. In fact, let me actually go back, and I'm going to create this, and then I want to show you So I've been using kubectl get. So kubectl get deploy Nginx tells us this. But if we were to say show it to us in YAML, it will show us the YAML, which, although it has a lot more information than the basic stuff that I had in my other one, most of the stuff is the same. Container, image. So you could actually use something like kubectl create and then get the YAML and save it yourself and then start working with it from that way. You don't have to create all of this YAML from scratch. We're going to do it this way because there we go. Because I want to show you some other things. We now have 3 replicas running. Because it's a deployment, we can start to use commands like kubectl scale. Scale the deployment, I want 5 replicas. All right, look at that. There's 5 replicas, okay. I want 1 replica. Cool, it's going to happily go off and terminate the other 4. When you are doing stuff with the deployment, you can also, see if I can make this work. It's probably going to just go too fast. Ah, there we go. So you can use kubectl rollout status, and it will give you a running update of what's happening as it rolls out the changes to whatever it is that you asked it to do. In this case, we just scaled up the replicas. Deployments also give you the ability to change the image, and it will do a rolling update of the deployment with the new image. If you want to be able to do rollbacks, you have to pass -- record when using kubectl set image. I don't know why that's not the default, but it's not, so just do it. All right, so we updated the image, and now let's interesting. Okay, we could actually sit here for the remainder of the class, and this would never change because there's an error. Error image pull and image pull back off. Now, it's important to point out that at this particular moment, 4 of our previous replicas are still running. So our application is still up, everything is still fine, our users are still hitting it, nobody knows that there's a problem except for us. But we need to know what this problem is. Image pull back off. Well, we can look at any one of these in 2 different ways. First, you can look at the logs of a pod. Well, but that one doesn't actually, it's not running, so there's no point in looking at the logs there. What we need to know is, how does Kubernetes see this? And for that, we use kubectl describe. This shows you how Kubernetes sees whatever the object or resource is. There's a lot of stuff in here that's interesting, but not at the moment. What we care about is down at the bottom in the events section. This tells you everything that's happened in the life of this little resource since its inception. It was assigned, it tried to pull a thing, and it failed because manifest for Nginx 1.15-alpn not found, because I spelled it wrong. Oh, well, okay. Computers do what we tell them to do, and in this case, it couldn't. So let's just roll this back. kubectl rollout undo deploy Nginx, and now it's killed off the ones it was trying to start. It started that one that was missing, and nothing was ever wrong. Let's redo this, but we'll do it a different way. We will edit the Nginx deployment. So I am down here, and when you run kubectl edit, it actually goes out to the cluster, pulls back the YAML for whatever the resource is, displays it in your editor of choice, and then lets you change it. If you screw something up where it can't parse the YAML, it will actually reload it and tell you what the error was. In our case, we're just going to change that to 1.15 Alpine. And let's watch the rollout. And now it should actually roll out successfully. Deployments are one type of what's called a controller in Kubernetes. Deployments create replica sets and pods. There are other types of things. Deployments are stateless. Well, the workloads that a deployment creates are stateless. Stateless means that no one pod is any more important than any other pod. Your traffic can land on any of them and be fine. You can delete one of them and everything's fine. They're not special. Not all workloads are not special. For example, databases. If you have a master and 2 slaves, well, those pods matter. The master has to be the master, has to use the right storage, has to have a reliable name and IP. The slaves have to wait until the master comes up. There's unique magicalness. So for that, you would use a stateful set instead of a deployment. There are also daemon sets. A daemon set will put one copy of the pod, will put one replica on each node in the cluster. If you have a 3-node cluster, you launch your daemon set, 1 pod on each, you got 3 pods. You add a 4th node to the cluster, poof, it magically gets its own pod. That's a daemon set. Then there's a job. A job is a thing that starts up, runs once, and exits, and Kubernetes will not restart it. If you want it on a schedule, then you would use a cron job, which runs jobs on a schedule. You would use that for something like, I don't know, cluster cleanup jobs, or running backups, or purging caches, or stuff that just needs to be run occasionally and doesn't need to be running all of the time. So deployments, stateful sets, daemon sets, jobs, and cron jobs. Those are your 5 main controllers within Kubernetes. Whew. So now we got a deployment. That's cool, but we can't really talk to it. I'm going to skip all this. I already did that. Services. Now we're starting to get to where we expose things to other things. Pods are ephemeral. They might be here today, they might not be, the node could get deleted. They have IP addresses, but you can't, they're totally unreliable. You cannot, I say that jokingly. They're unreliable in the sense of you don't know that that particular pod will still be alive if you try to talk to it in a few minutes. Probably it will be, but things happen. They are reliable in the sense that Kubernetes will keep them running and do whatever they need to do. But my point is, you don't ever want to talk to a pod. Instead, you want to talk to a service. A service keeps track of a group of pods and provides a stable DNS entry and IP address so that when you talk to the service, you talk to the pods that are behind it. And that's cool. There are 3 different types of services. There's a cluster IP service, which creates an IP address only accessible within the cluster. Imagine that you have a web server deployment and a database stateful set, and you want the web server pods to be able to talk to the database. You can put a service up in front of the database pods and talk to it that way. But you don't need to necessarily talk to the database pods from outside the cluster, so cluster IP service is fine. But you do need to talk to the web server pods from outside of the cluster. So you could create a node port service. A node port will open up a high port on every host in the cluster, somewhere between 30,000 and 32767. And if you hit that, it gets routed to a cluster IP service, which gets routed to the pods. You're not going to use this for anything real. You're not going to say, oh, my website is example.com:31234. This is used when you have an external load balancer, like I don't know, F5 Big IP or a 10 something or whatever, some external load balancer, and you want it to be able to talk to the services. So you would create a node port service, and then you would put the hosts from your Kubernetes cluster into the node pool inside the load balancer, and everything would be fine. If you are deployed inside of a cloud provider like Amazon, you can actually automate that whole thing by creating a service of type load balancer. This will create a cluster IP service, will create a node port service that maps to the cluster IP service, and then it will reach out to Amazon's API and it will create an Amazon Elastic load balancer. It will populate the ELB with all of the nodes in your cluster where the node port is listening and with the corresponding port. And it will maintain the health of that information. So as you add and remove nodes, if IPs change, anything at all, the service will update the ELB. It looks like that. A service also has YAML. You could create it by yourself if you wanted, or you can just expose a deployment. First, let's expose our Nginx deployment as a node port. You can see that we now have an Nginx service. It's a node port, and it's listening on 32608. So if I jump out to my browser, there's our Nginx page. Okay. That's interesting, I suppose. You can specify the node port. If you wanted to do so, you can. You just have to pass it as another flag. How else can we do this? Well, instead of using kubectl expose, let's actually create a service. So in this case, we want to create a node port service like that. And so we can tell it what port we want, and then we can tell it what to map that through to at the cluster IP level and at the actual container level. And you see now we have the same thing. We have a node port service, but it's listening on a different port. All right, well, for the next part, for example, my house isn't an Amazon availability zone, so I can't really make a load balancer. So while making node port services is interesting, there's actually a better way to do it. All right, so I've just recreated the service as a cluster IP service, so it only exists within the cluster and it's listening on port 80, because now I want to introduce you to Ingresses. Even when I had a cluster out at Amazon, I didn't use service of type load balancer because that makes a single ELB for each website that you're running inside of your cluster. So if you're running dozens of websites, which is not out of the question, that's $20 a month for each website that I had to pay to Amazon. And I'm not going to do that. Instead, I want to run a layer 7 load balancer directly on my cluster. And that's called an ingress. So an ingress receives traffic, does some processing on it, hostname, path, figures out where it should go, and then routes it internally. The thing that does this is a software load balancer, usually by default the Nginx Ingress Controller, but you can also use HA Proxy, Kong, API Gateway, Glue from Solo. The Istio has ingress support. There are tons of things out there that do ingresses. And they look like this. Traffic lands on the ingress. It makes decisions based on hostname and path, port, various. It can also do layer 4 stuff. Sends it to a corresponding service, which goes to the corresponding pods. The layer 4 stuff is important because if you have something running inside of your cluster that is not an HTTP endpoint, such as MQTT, SMTP, anything that's already TLS encrypted, you don't want an HTTP load balancer screwing around with that. So you would just map the ports directly through. And you can still do that with a standard Ingress controller separate from the layer 7 functionality. Here is a single ingress. So you see that it has rules. The host is our host name. We're going to send / to the Nginx service on port 80. With that, I can come over here learn how to type. And now with no port, here we are on our cluster. This is a really boring demo though. I'm going to change this to something that's cooler. I'm going to change this using the stuff that we've already learned to a much cooler demo. So let's look at what we have. We have a deployment called Nginx. If we look at that, it is running, oh, that's interesting, way down there. It is running Nginx 1.15-Alpine. Well, I'm going to change that to run Ingress / Rancher demo pink. We'll wait for this to update. All right, so it's updated. I'm going to come back over here and I'm going to refresh that and oh, bad gateway. Okay, the reason for that is because that image that I launched listens on a different port. So let's update our service. So I'm down here now, and let's tell it that it needs to send traffic to port 8080. now, here we are. This is showing you one rancher cow for each of the 5 replicas that we have. It also shows you which one is currently receiving traffic. And as time passes without hearing back from a particular replica, that replica will slowly fade into darkness. We can update this Let's say we want to run the yellow. And let's look at our rollout. All right. So it's updating. And if we come over here, you'll see yellow cows start coming in. And over the course of the next period of time, the pink cows will fade away. When we've got 5 yellow cows, our rollout is complete. That's a much cooler demo. That demonstrates how easy it is to do things with Kubernetes, because remember, all you're doing is assembling blocks. So now what if we were building a microservices site and we had different deployments for different pieces of our application? So we had /products went to one set of pods and /profile went to something else. Well, we can do that now with, it's called a fan out ingress. This is almost identical to what I just showed you, except we're sending one set of things to one place and another set of things to someplace else. In this case, we're going to send /rancher to a service called demo that doesn't exist yet. First, let's delete our ingress. We should now be seeing errors because there's no more ingress. And if we apply the fan out, now we're getting traffic again, no more errors. But if we try to go to /rancher, well, that doesn't exist because obviously we didn't create it. So how can we do that? How about if we create a demo deployment using our same awesome Nginx image. Let's expose that to create a cluster IP service. And now that we have, let me show you this fan out again. So fan out is looking for a service called demo, and that's what we just created. So if we come back over here and refresh this, we're up. So /rancher is going to one set of pods, and / is going to a different set of pods. That's Kubernetes. The rest of this is Rancher stuff, but I'll pause here to talk about Kubernetes specific things if there are any questions. Matthew, do we have questions?
Hey, Adrian, awesome demo. We do have a couple questions, but it's only on Rancher. So
okay.
No questions just on Kubernetes. You want to keep going and then we can...
Yeah, I'll just keep going. Yeah, if any of you think of any Kubernetes questions, you can still ask them. I'll just answer them at the next part. Everything that we were just doing, we were doing on our cluster that we deployed at the beginning of this class. This is the training cluster, and it has 2 projects. One of those inefficiencies of Kubernetes is how it applies role-based access control. I told you about namespaces, places. It's a logical isolation that separates things that are similarly named. Dev, staging, production can all have something called website. Now, if you had one team of developers who needed access to that dev project, that dev namespace, that's not a big deal. But imagine that you had 25 different websites, each of which had their own dev, staging, and production namespace. Now you have developers who need access to 25 different namespaces, and you have to do configuration on 25 different things. Not so fun. Rancher solves this by collecting namespaces into what are called projects. You apply role-based access control to the project, perhaps the developer project, and it propagates to all namespaces that are part of that project. Now you change something in one place, you don't make mistakes, and you get all of the impact the way that you should. Rancher stands up two projects. A system project that has system level stuff that you just should leave alone. But if you do need to deploy system level stuff, you would deploy it into this project. The other one is the default project. And that, by default, is empty. Now that's where we've been working. We've been deploying things into the default namespace, which is part of the default project. So you see here, we have our image. We have our two deployments, demo and Nginx. We have the services that were created. We have the ingress, and we didn't get into storage or any of those other things. If I wanted to edit one of these, say for example, this guy, well, I can just come in and I can change this to black, for example, and say upgrade. Everything that I'm doing through this web interface is actually talking to the Rancher API, and the Rancher API is communicating with the Kubernetes cluster to execute the commands that we would have otherwise done with kubectl. It's just an easier, faster, more friendly way to do things. There are things within Kubernetes that I don't have time to show you. But if you deploy Rancher, you can come in here and you can say, okay, I want to stand up new app. What do I want? I want a daemon set. I want a stateful set. No, I want a deployment with 3 pods. This one is also going to run Rancher demo. It's going to run pink. We're going to put it into a new namespace called Adrian. It listens on port 8080. We want that to be cluster IP. And now let's talk about things I haven't shown you. You're installing something from Docker Hub, and it says, oh, create an environment variable of whatever. So great, you can add those. Kubernetes has config maps and secrets. Config maps are collections of information that are not encrypted, and secrets are collections of information that are encrypted. And then you can bind those into a container as either files, environment variables, storage volumes with multiple files in them. You can create config maps and secrets up here. And once they've been created, you can add them down here. So you could say, oh yeah, include whatever this config map is as environment variables or as a storage thing or as whatever. You can do node scheduling. You can configure health checks to tell Kubernetes how to figure out if a container is alive or dead. Kubernetes can even run commands on a container to determine its health. It doesn't need to be listening on a port or serving HTTP traffic. You can do stuff with storage. Storage is one of the most complicated things to do within Kubernetes. It's unpleasant. I'm trying to choose my words carefully here. It's unpleasant. You can read into that whatever you like. With Rancher, you could simply say, oh, you know what? I want a new persistent volume claim, and we're going to call this whatever. If we had persistent volumes previously mapped to the cluster, we could select one. Or if we created a storage class, we could select that here. Storage classes are dope. Storage classes separate the responsibility of the cluster admin from the user. With persistent volumes, if I'm the administrator of the cluster, Bob from development says, hey, I need 10 gigabytes of storage. I have to go and create 10 gigabytes of storage, make it available as a persistent volume, and then tell Bob, okay, you can use volume 1, 2, 3, 4, 5. That makes me the bottleneck. If Bob works on a different schedule than I do, Bob has to wait for me to get around to making that. And that makes Bob angry. And we don't like when Bob is angry. So instead, as the cluster admin, I can create what's called a storage class. I tell the Kubernetes cluster how to go get storage. Yes, storage class, you can provision storage from Amazon Elastic Block Storage, or iSCSI, or NFS, or whatever. There's dozens of different storage volume drivers for Kubernetes. So I've told the cluster how to make that storage. And then I make that available as a storage class called whatever, Amazon. Bob says that he wants 10 gigabytes of storage, and he simply selects the Amazon storage class. The storage class driver goes out, gets him 10 gigabytes of storage, creates a persistent volume, brings it back, shares it with him, and he doesn't need me. He can just do what he needs to do. all of those things can be done from within this volumes thing. Bob could just come in and say, you know what, I want a new persistent volume claim of whatever, and I want to mount it on /data, and we're going to call it my data, and there it goes. You can control how pods are updated. Do they stop and then start? Do they start and then stop? What's the batch size? And then there's a whole mess of advanced options down here that give you super granular control over all sorts of other things that happen within Kubernetes. So you can do all of this stuff just within deploying a workload from one interface. So things that I haven't even shown you how to do today, you can figure out and do from here. If you have existing YAML, for example, if we took that pod manifest here and just pasted it, oh, there you go. Now we have a pod that's starting and stopping and starting and stopping, and in a minute, it'll do everything that you already saw it do. We could come in and we could edit it. We can edit the YAML directly if we wanted to. In this case, let's just delete it. So Rancher ships with, wow, I'm gonna end up really early today. This is cool. I may get to show you guys more things than I normally have to. We normally have more people and we also have questions. So this part, I'm not usually at this part for about 15 minutes from now. Rancher ships with a whole bunch of other tools. Remember day 2 operations? So you've got a Kubernetes cluster. Well, now you're gonna have to monitor it. Now you're gonna have to set up notifications. Now you're gonna have to monitor the workloads inside of it. Now you're gonna have to figure out how to plug it into a CI/CD system or into your code repos so that you can actually push code and have it show up in your cluster. These are things that you should not have to figure out. They waste your time and they take time away from your ability to just do whatever it is you need to do. Kubernetes is a tool. Like, you don't go buy a hammer and then spend 6 months learning how to use it. You want to just go hit a nail with it. Or, well, you want to hit something with it at least, maybe not a nail. But anyway, you don't want to spend the time learning how to use it. If you already have something like Jenkins or Drone or some CI/CD system, then you can just plug that directly into Rancher or via, into Kubernetes, and the means of doing so are already there. But if you don't, you can create, you can create pipelines to bring stuff in directly from your repositories. So when you push code, Rancher will go out, build things, update workloads, and deploy stuff within Kubernetes. It's based on Jenkins, but it's a very lightweight implementation of it, and it's just designed to get you up and running with the continuous deployment portion of CI/CD. I've already shown you that you can enable advanced monitoring. I can't do that in the class because I'm running on a small instance. But once you have monitoring in place, you can add basic alerts by default, but you can add more advanced alerts with the advanced monitoring. So you can create cluster level alerts. So there you go. So alert groups for various things. You can create notifiers. Who do you tell when there's a problem? So you just give us your Slack info, email, PagerDuty, arbitrary webhook. If you're in China, you can use WeChat as well. Clusters are automatically snapshotted. We take snapshots of clusters. Clusters that are deployed via Rancher, so using RKE, have snapshots taken and archived at set intervals. etcd is the data store of Kubernetes. As long as you have a backup of etcd, you can restore your cluster to that point in time anywhere in the world. Obviously, you don't get the data, but you get all of the Kubernetes parts. What's running, how's it configured, what's the storage, where is it mounted, all of that stuff. You can restore that. So you shouldn't have to figure this out. You should just get it. So you do. And if you have advanced options, There we go. If you have an S3 endpoint, either S3 or Minio or any S3 compatible storage, well, you just give us the name, tell us where it is, give us the credentials for it, and we will automatically upload those backups to S3 for you. So now you don't even have to worry about the offsite storage component. I just did a video on using Minio with RKE and Rancher to get backups if you're somewhere that doesn't have S3. So that's on my channel as well. A snapshot was taken of the cluster when it launched. Go back to workloads. None of these things were here. Let's do this. Let's take another snapshot right now, because let's say that we're about to do some maintenance on the cluster. I don't know what we're going to do. So we're just going to take a snapshot. Boom. That was easy. Let's just check our snapshots really quick. Make sure that snapshot finished. Yep, a few seconds ago. Let's come out here. Let's delete this. Boom. All right, so we gave Bob from the development team too much access, and he nuked the CEO's private Bitcoin mining software or whatever. And the CEO comes to us and is like, hey, you know that thing I was doing that I'm not supposed to be doing? Can you make that happen again? And we just say, yeah, sure. We come out here, we restore a snapshot from a few seconds ago, and it will go off and it will restore that. And if my demonstration skills don't suck, in a few minutes, we will see that. Now, while that's happening, I wonder if I just destroyed my ability to continue to show you stuff. Maybe. Let's see. I totally did. It's updating. Okay, so it's restoring from a snapshot. So while it's doing that, I will actually jump out to a different Kubernetes cluster. And I will show you the application catalog. I talked at the beginning about Helm charts. Remember I said you can enable the stable Helm repo or the incubator, or I said that Rancher ships with a curated list of charts. This is my Kubernetes cluster that I run in my house because I'm one of those guys. So I use it for home automation. I run Plex on it. I use it for my own private Dropbox server. I use it for task synchronization with Task Warrior. I run backups on it. I run my own private certificate authority. I run my Unify management utility for my ubiquity access points on my property. I run Logstash against an Elasticsearch cluster that I also have in the house. I have various other things down here for doing stuff, and this is what I run at home, including a full installation of Node-RED that handles all of my home automation, and MQTT server that handles communication for presence detection, and my solar energy system, and a bunch of other home automation stuff. You can run Kubernetes in your house, and I encourage you to do so. If you have this kind of tool available to you, you will figure out what to do with it. And if you're just learning how to do stuff with Kubernetes, there's no better way to learn than to force yourself to learn. So you say, okay, I'm going to make a Kubernetes cluster, and when I want to run, whatever, C-file, I want to run Apache, I want to run a wiki, I just want to run something in my house for myself, and then care for that thing like it's a little plant that you want to grow into a tree. And when it breaks, put it back together and play with it and figure out how to make it into whatever you want it to be. And by doing that immersion, that's how you will get better. This is the app catalog. This is so this is just the Rancher library. Imagine that it's later on this afternoon, it's 2 hours from now, you've got Rancher installed, you've got a Kubernetes cluster, and you're like, you know what, I want to install WordPress. Well, WordPress needs a database. So the first thing I'm going to install is actually MariaDB. Well, you're not going to go out and figure out how to install MariaDB in Kubernetes this afternoon. You're just not. Instead, you can come here to the app catalog and you can say, oh yeah, so I want it to be called MariahDB. It's going to have that admin user. We're just going to generate a password for it. Let's create a database called Adrian. Let's use a persistent volume from the NFS client storage class. It's going to be 8 gigabytes. Let's disable replication because I don't care. Let's create a cluster IP service because I don't need to talk to this from outside. And let's not enable metrics. This will create all this YAML for you, and it will swap in all of the values that you've entered up above, and it will launch and it will create a multi-node MariahDB cluster. So literally you can have, I'm not going to click launch because I don't need this in my house today, but literally you can have a 3-node MariahDB cluster up and running in a few minutes, and now you can start to use it. And that's, I've said that several times throughout the class. Like, the point is to get you past the installation phase of things and onto the using it phase as quickly as possible. So that's the app catalog. All of the stuff that you see here that's from library is curated by Rancher. It's stuff that we ourselves use, and some of them are from our partners. So they're things that we know are going to work. If I jump out to yet another Rancher installation, I can show you the kind of stuff that's in the stable Helm repo. This is my production Kubernetes cluster that I run out in DigitalOcean using the DigitalOcean Kubernetes service. So this hosts my website, my wife's website, some internet, public-facing stuff, and some friends' websites and things like that. But now, if I went to apps and I went to launch, and I change this to just the Helm repo, well, there is a ton of applications here that you can just install basically with a single click. You just answer some questions and start doing stuff. I mean, I'm like a third of the way down the page. You can see there's just tons and tons of things. It's like if you use Linux, nobody builds anything from source anymore unless you're still on Gen 2, or FreeBSD, which, I mean, if you are, that's cool too. But package managers, it's the wave of the future. So you are going to use apt-get install. You're not going to, build stuff from source. Same thing. You don't want to build stuff from source with Kubernetes. You want to use packages if they're available. And if they're not available, then you want to make the package and you want to contribute it so that other people can benefit from the work that you've done. Let's see if there's anything I've missed. If I come back over here, our cluster's back up, and I should be able to come over here. Oh, look at that. Our application, our CEO's Bitcoin miner, is back up and running. He's making pennies a day and living a life of luxury. So I think that's pretty much it. We got about 15 minutes left, so I'll just take questions.
All right, awesome, Adrian, thanks. There's just a couple questions, but each one is pretty hefty, so let's dive in.
Bring it.
Yeah, here we go. So this first one is from John, who says, I'm interested in a competitive comparison between Rancher and OpenShift, and if Rancher supports KVM, LXC, and major distributions like CentOS, SUSE, Oracle Linux, and alternative atomic builds.
Woo! John, was that the man? That's his name?
Yes.
John, I love your question, bro. Okay, first of all, Rancher, there's like 18 questions in there. Rancher Kubernetes engine, our Kubernetes distribution, can run on any Linux with a supported version of Docker, period, the end. So that's good. So that means, yes, SUSE, Oracle Linux, CentOS, whatever you can install on it. That's fine. And you can then also run the Rancher server in any of those. Now, Rancher is 100% free and open source. We do have enterprise subscriptions. And so for our enterprise customers, there's an entire layer of quality assurance that goes into the product where we guarantee that Rancher will operate on certain platforms. So we have a list of officially supported platforms, but honestly, it'll run anywhere that you can run Docker. As far as LXC, KVM, well, so KVM is a virtualization engine. You can run Rancher, so I can answer that in a couple of different ways. This is the Proxmox cluster that I run inside my house. So I've got a 5-node Proxmox cluster. These are 5 physical nodes on which I have a whole bunch of LXC containers as well as a whole bunch of virtual machines. Notice that these are KVM virtual machines, and that's where my 4 Rancher nodes that run my home cluster are running. So KVM being a virtual machine engine, you can run Rancher inside of VMs running on KVM, but I mean, that's kind of obvious, I think. And I don't think that's what you were asking, but that's the only way I can answer KVM. As far as LXC, because LXC is its own container engine, there are ways to run Docker inside of LXC. You can find stuff online about it. And I looked at doing it because I considered running Rancher inside of LXC containers because they're faster and I like them and they're a lot easier to work with than full-blown virtual machines that hog a bunch of RAM. However, for me, it wasn't worth the headache. It's also not going to be a supported solution. And if you have a place to run an LXC container, then really you can just run Rancher in Docker on the VM itself. So that's that. As far as competitive between OpenShift and Rancher, that's a big question that I will answer briefly. We run into that. Red Hat is our #1 competitor. Red Hat has a particular way that they are solving problems in the marketplace. OpenShift 4, I've looked at it. I don't actually have a lot to say that's bad about it. They use operators. Their whole inception-y way of building things and then continuing to build from the things that they build is really smart. Their engineers are obviously really talented people, but they're targeting a developer audience. They're targeting a world where you run one big cluster for your entire organization, and all of the tools that it has are really targeted towards making it easy for developers to do stuff without having to learn things like Docker files or how all this Kubernetes nonsense works. Maybe that's right for you, but that's not right for everybody. There's a whole other universe of people out there that recognize access to multiple clusters is how you maintain separation from cloud providers. Right now, if you only get one cluster and you can only run your stuff inside of Amazon, for example, and you can only use Amazon's tools, well, if Amazon changes their pricing and you don't like it, too bad. What are you going to do? You're going to have to make a decision of if it costs more to move to Google than it does to just pay whatever they're trying to make you pay. This is not only true of Amazon, it's true of Google, it's true of Azure, it's true of Red Hat, it's true of IBM, it's true of Rackspace, it's true of everybody, because these businesses exist to separate you from your money. The way that you maintain freedom is you use a solution that treats Kubernetes from anywhere as a commodity. Rancher abstracts clusters running on EKS in Azure, on cloud compute instances, into a model that provides a uniform language for how you deploy stuff. You can't directly lift an application out of Amazon and drop it into Azure, but you can take the YAML that's running there and running from inside of Rancher. You can have an Azure cluster and an AWS cluster inside of Rancher, and you can just copy and paste the YAML from one to the other and essentially do a full cloud provider migration from within the Rancher interface. When you get into cloud provider uniqueness, like storage, for example. Obviously, if your workloads are using something like Amazon Elastic Block Storage, then there's no corollary for that inside of Azure. If we're just going to stick with those two providers. You look at something like Longhorn or OpenEBS or StorageOS or any of the vendors that provide container attached storage, and they become an abstraction layer between the Kubernetes cluster and the storage. So now you could build a new cluster out in Azure using Longhorn, for example. That's our container attached storage solution that is still alpha, but it's going to be GA later this year. So you could build something with Longhorn, you run Longhorn stuff on both clusters, and now you can literally copy your YAML from one and paste it in the other. So if Amazon comes along and is like, hey, we're going to charge you 6 times as much money, because what are you going to do? Well, you're going to leave, because now you can. You're not going to be able to do that if you are part of the Red Hat ecosystem. I guess not the IBM ecosystem. Rancher is 100% free and open source. We only make money if our product is good, because our product is free. So if our product sucks, why would anybody pay us for support? Our product is really good. We have over 300 enterprise customers that pay us for support, and that's how we maintain our entire operation. That's how we're able to give the product away to everybody else. Our interests are entirely focused on making sure that you stay free and that you stay able to do what it is that you need to do for your business, for your needs, for your goals, not whatever Red Hat wants you to do, because that's all they're going to let you do so they can keep you in their little box. I don't have any strong emotions about that at all. I think I'm just going to stop there and we'll go to the next question.
Preach it. Oh, man. Giving me chills, Adrian. So good. All right. So here is the next question. It's a very different question. This is from Troy. He says, Adrian mentioned storage class drivers earlier. Is there a way that a Rancher user can automatically provision a local node path persistent volume via a custom catalog Helm chart questions.yaml when instantiating a new app? It looks like a persistent volume requires a manual setup prior to launching a new app, and the questions.yaml can establish a claim but not create a new underlying persistent volume at the same time. I also had trouble establishing an external IP for an L4 load balancer via questions.yaml.
Oh, look at that. It's actually a Rancher thing. That's pretty funny. This is fairly recent. There's your answer. So apparently Rancher has has something where, yes, you can create a storage class that can provision a local path. And it looks like this will even work outside. This isn't Rancher specific. So you could run this in any Kubernetes cluster. And just skimming through this, create a config map. Yeah. So yeah, you could deploy this and it'll make a storage class available. And then people can utilize the local path storage class to create storage on a local host. Now, I don't personally recommend that you do that in anything other than a development environment, because if that node goes away, I'm sure you know this, if you're using the local path, then Kubernetes knows that it won't start that somewhere else than the host where it originally launched it. If that host is gone for whatever reason, then that workload just isn't going to run until that host comes back. So this is, I don't recommend this. Yeah, anyway, there are specific cases in like development environment or testing or whatever where this is fine. If you're going down this path because you don't have any network attached storage alternative, you're on-prem or something like that, you don't have a SAN or a NAS or whatever, there are other things that you can look at. For example, Longhorn. Longhorn, OpenEBS, StorageOS, all of these container attached storage solutions let you do really cool stuff. Like you can, it's abstraction. So I'm going to talk about Longhorn even though it's alpha, because it's our product and it's appropriate that I talk about it. And this is how it works now and how it's going to continue to work. You run Longhorn and it uses, so let's say you've got 3 nodes and each node has whatever, 500 gigabytes of disk or a terabyte of disk on it, but it's not using that much of it because it's just, it's a Linux node. So you've got 492 gigabytes of disk available on each node. You run Longhorn and it grabs all of that storage and says, okay, I have a storage pool now of whatever that comes out to, 1.2 terabytes, change, 1 point, whatever. Anyway, a lot. Math is hard. So you've got all this storage in Longhorn, and then Longhorn enables a storage class, and when somebody says that they want storage from whatever, it provisions storage with replicas on each of those nodes. So the replication part is important. It's block level replication. So it'll create a replica on all 3 nodes, and then as data is written to one of them, it replicates it to the other 2. You can then run, you can either use that directly where you could have, a MySQL master that's got its storage on replicated storage. That's cool. But if you wanted something where you get multi-node read-write or read-write many, which is where you can have that storage attached to multiple pods. So think NFS. You can actually do stuff where you can launch an NFS storage. So you can launch an NFS storage class that uses Longhorn storage and makes that storage available in the cluster. So now you have replicated block level storage that's the backing storage for an NFS server running inside of Kubernetes. And that NFS server is enabled via a storage class so that now your workloads can say, oh, the website, for example, or whatever I need read-write access to on multiple pods is actually happening over NFS. So it's another layer of abstraction that gives you network storage functionality without needing to have external storage available, like a SAN or a NAS. So those are two types of solutions that you can use instead of using local path or host path or whatever this kind of thing is, if you are still in a resource constrained environment. I hope that answered your question.
Awesome. Thanks, Adrian. That was the last question, actually. Yeah.
Did John log off after my Red Hat tirade?
No, he asked if this was being recorded. So I think that's a good.
It is being recorded. All right. So I want to thank you all again for coming. I really wish that our classes were interactive. Like, I spend my time talking to this little 360 microphone on my desk, but I really feel like I'm talking to you. I try to be engaging and funny and still give you guys rock solid information that you can leave from this class today and immediately go out and use. So I hope that I've done that. I do that on my YouTube channel that I just launched a month ago. Since it's only been up for a month, I don't have a cool channel URL. So that's llb.io/ytmona, or you can just search on YouTube for Adrian Goins. I'm the funny looking guy. You can also follow me on Twitter, Adrian.Goins. You can find me on the Rancher user Slack at Adrian, and you can find me on Instagram at Adrian.Goins. I'll tell you a funny joke. I live in Chile, and in my video last night that I was recording, I wrote the script for it, and I talked about how I live on this, I meant to say like this really great farm in Chile, but you've heard I like to use the word dope because, whatever. I'm like, oh yeah, that's totally dope. So I was like, yeah, I live on this dope farm in Chile. I was like, oh, wait, that's not what I meant to say.
It doesn't work.
So on Instagram, I post photos of my really cool farm that I live on in Chile, which has a bunch of endangered creatures that live on it that we always find walking around, and they're pretty cool. So please, those places give me an opportunity to actually interact with you, to make videos on the things that you would like to see, to get feedback from you. So please check those things out, follow me, tell me what you'd like to see. Tell me how I can help you, because I just want you guys to be successful. So with that, I'll hand it back over to Matthew, and this will be like the first time that we've exited on time in like 6 months.
Okay, amazing. Let's see, can you see my slide here?
Not yet.
Okay. There we go. Okay, cool.
There you go.
Awesome. Yeah, thanks so much, Adrian. Thank you, everybody, for your questions and participation. We hope to see you on Slack. Just in case you missed this, slack.rancher.io, where our community hangs out and continues the discussion.
Hey, Matthew, I really hate to interrupt you, but I swear to God, like right this second, there's an earthquake. I got to go. I love you guys. Okay. I'll see you later.
Okay, bye. Wow, he really is in Chile, everybody. Okay, so that was... I'm going to have to check in on Adrian later. He is Adrian on Slack, so definitely check in on him, see how he's doing. We're so happy you all could join us. I'm just going to wrap this thing up. There is more classes that we do every week. Our masterclass series has a ton of different kinds of topics, so check that out. Rancher.com/Kubernetes masterclass. Next week will be our Director of Community, Jason Van Brackle, presenting on setting up automatic alerts and visualization of metrics for Kubernetes clusters and apps. And if you like this presentation, let us know on Twitter, #RancherK8. Just give us a shout out, and we, be part of the community. We'd love to talk. So thanks, everybody. We will send this recording out and the slides later today. So look for that in your email. All right, have a good week. Talk to y'all later.